Hi, Lou Covey, Editorial Director of New Tech Press, and I'm here in Redwood City, California at Woodside High School talking to some of the members of Team 100, the robotics team for the Sequoia Union High School District, and talking about what their plans are for the championships in St. Louis in the next couple of weeks. Chris, what were you trying to resolve or solve for this project you're doing?
So basically, the game, it's 3-on-3, and we're basically playing basketball. So I mean, you have to pick up one of the basketballs, carry it over, and then shoot it into one of, well, four hoops, but basically into the top hoop.
Okay, now are you doing this with just your robot, or there's other robots that you're playing against?
Yeah, so it's 3-on-3, so it's three robots on either side. There's actually enough basketballs where we can each have some, but basically it's basketball. So there's defense, there's different strategies. It's pretty cool.
Okay, so what were you using to actually make this particular robot?
Basically, our frame's all made out of aluminum, and then we have motors that drive the intakes, the shooting, different transport.
Now, what is this we're looking at?
This is called a CNC mill, and basically what it does is we give it instructions in a computer code, and then it mills out. So basically, it goes down, drills holes, but also cuts out sections of exactly what we want. And you don't have to worry about imprecision. Well, a little bit of imprecision, but a lot of it's better than doing it by hand. And so basically, this can make a lot of parts that otherwise you couldn't make. So this is our welding shop, and basically, we weld, so it's melting metal together in order to make it, one piece. And we actually didn't use it as much this year, but usually we make our frame by welding it together.
Where do you get these materials?
So some of them are provided by First. We get like this kit of parts that has a bunch of them, and the others we buy from different people. Like there's websites Andy Mark, Bainbots, but basically they sell the motors and other parts to us.
Okay, and what do you plan to do after this?
So I'll be going to Stanford next year. I'll probably do some sort of engineering, probably mechanical, but I really don't know yet.
Okay, thank you, Chris.
Yeah.
Now, you are the electronics guru for the team, right?
I guess you could say that.
You could say that, okay.
Yeah.
Now, what is it you were trying to resolve with this particular project?
So there are a few problems that we came across this year. The first one, which was where the Arduino sort of came about in it, was that we had so many inputs from a ton of different sensors. We have limit switches everywhere in this robot to track ball movement and things like that, and other sensors. And with the board that First supplies to us, called the digital sidecar, there were not enough inputs in that. And so we decided to use an Arduino and use all the digital inputs with that for some of our sensors, and then communicate that over I2C to the digital sidecar so we could integrate all the sensors that we needed to into the robot to make everything work how we wanted it to.
Okay, so you decided to use Arduino. Why did you choose that over things like BeagleBone or anything else like that?
Well, so I have a little bit of experience with Arduino at home, just messing around with things. Mm-hmm. And some of our mentors, know a little bit about it as well. And so we decided to go with something we were a little more familiar with, mm-hmm. Just because we felt that would give us a little more of an edge and it'd be easier to do it a little.
Okay, so what is this thing?
So this right here is a Thingomatic by MakerBot. It's a 3D printer, and how it works is it heats up plastic from a reel like this, and it extrudes it out, and it's all computer controlled, and it'll build up layers of plastic to end up with a solid 3D model mm-hmm. that you can design in the computer and then just print out in a relatively short period of time.
Now, are you using any of these parts that you've made in the current robot?
Yeah, so we have a few parts. I think right now the main thing we're using it for is to make small brackets for limit switches, and besides that, we've been experimenting with some different parts, making little clips and things like that. So I think we plan on using it a lot more next year.
So what are you going to do after this?
Me personally?
Yes.
Well, next year I'm going to be on the team again.
Mm-hmm.
And then after that, I plan on going to college and studying mechanical engineering.
Okay, so I just talked to the mechanical guy, and he's talking about going to Stanford to be an engineer, and you're the electronics guy, and you're thinking about going to mechanical engineering, right?
Right. So I still enjoy electronics.
So you're so young, and you're sick of electronics already.
No, I wouldn't say that. I think I really like the mechanical things, mm-hmm. and I want to be able to do those, but I also want to be able to integrate electronics into that. So I know at a few colleges they have what's called mechatronics, mm-hmm. which is essentially, I think it's mechanical, but it integrates the electronic components into things like robotics and stuff like that. So I enjoy the electronics, but I also really enjoy mechanics.
What particular problem were you trying to resolve?
So this year we were trying to use a camera on the robot to find the targets on the field. We also had to make sure that the shooters on the robot could spin at the right speed so that when we shot the balls they would go where we wanted them. And then we also had 2 sides to our intake with a jam point in the middle. So we had to make sure with a lot of sensors to make sure that none of the balls would come into the middle and jam.
Okay. So what particular software platform were you using?
So we use C++. We work with Wind River. Last year we used LabVIEW. We switched this year because we thought C++ would be better. And we also use Mercurial for our source control.
Okay. And did you run into any particular problems in the development of this program?
Yeah, so since this was our first year using C++, we had a couple new people, we had to make sure that we had to teach all the new people how to use the software and how to program. We also encountered a lot of problems with our source control, where one person would be working on one part of the code and then another person would be working on the same, and then when they all came together they'd all get mixed up and it would break everything. So we hit that problem a couple times, but we figured it out in the end.
So basically it was a problem with intellectual property.
Yes. Yeah, that was fun.
What year are you at school?
So I'm a senior.
A senior? So what are you going to do after this?
So after this I'm actually going to Berkeley next year,
Mm-hmm.
and I'm probably going to see if I can find another robotics team or something like that.
Okay, what are you going to study at Berkeley?
I'm going to study math and computer science.
All right. And what do you plan to do after that?
After that, I don't know.
All right, very good. Thank you.
Davie now, scorching temperatures proved to be way too much for some young campers who were overcome with heat exhaustion. Local 10's JC Birch is there live now. And JC, how many young people are we talking about here?
336 kids at the camp, but we're talking about 14 kids that suffered from the heat exhaustion. You know, Calvin, the situation here was this was supposed to be the last day of junior ROTC camp. They say goodbye to camp, they say hello to mom and dad, but the heat was just too much to bear. So right behind me on these campgrounds, 14 teens suffered heat exhaustion, with 6 being transported to local hospitals. All succumbed to the dehydration, but thankfully they are all going to be okay. Now they're being released to their parents at the hospital, and the chaperones first noticed something was wrong when the teens began to feel faint and dizzy. Those who were suffering from dehydration were told to sit down, drink plenty of water, and medics were called out here to the camp.
We've been out here now since last Sunday. We're breaking up camp today, so the youngsters get pretty anxious to get all their bags together and move around. It was extremely hot. Obviously they weren't drinking enough water, and we started seeing the heat injuries.
Now, the interesting thing here is that for the last 5 days, these high schoolers have been in serious high adventure training. You're talking about rappelling, rope, and obstacle courses. That kind of outdoor activity requires the teens to drink at least 2 canteens of water an hour. And there was only one heat exhaustion problem all week long. But since today was the day to pack your bags, clean out the tents, get ready to go home, what I'm told is that all those teenagers, these were freshmen, sophomore, and juniors, ages 14 to 17, they were so excited to leave that they weren't focusing on drinking that water. So there was the problem. When they're active, they're thinking about the water. When it's time to go home, they forgot about it, and that led to the problems. But thankfully, Calvin and Lori, everybody's going to be okay.
That is great news out there. What rough kids they are. All right, JC Birch live in Davie. Rough and tough.